We already talked about MIPS and the assembly language. This is the compiler. We already give in the link in description. You can follow through this and come here and test or run a code. So I write a code for print hello world. So let's compile the code, compile and load. After compiling the code, here is the message. If the code runs successfully, then this is the message compile success. So we can now step by step check what is happening behind our program. So step, let's we use this all memory. You can see here the memory is using. Here we call the memory, then here, then at last we print it. Here is the result, print hello world. So that's how it's work. You can explore more to learn these things more. So let's go to our today lecture, which is MIPS instruction format. Let's discuss about this. MIPS MIPS instruction format. All MIPS instructions are encoded in binary. All MIPS instructions are 32 bits long. All instructions have an opcode. First 6 bit. There are 32 register. Is for net 5 bits. Why 5 bits? You can calculate it from here. 2 to the power 5, which, which is 32. So there are three instruction categories: I format, J format, R format. These are the most common. Now let's learn about I format, which is opcode. Opcode mean instruction we said. This is the two register RS and RT, then immediate. Immediate mean this the value 4 and RT is the TS and this is T2. In J format, OP is this one, this instruction. We use J format for jump, unconditional jump, and the address is this one. Then R format, which is we mostly use, this is opcode in RS, RT, and RD. RS mean S0, RT mean S1, and RD is S2. And for add operation, we use function in 1000. For add operation, we use this. If we use shift operation, then we can use this one. Because there is no shift, we don't use this one. So this value is 0. Basic I format have two register and constant value immediately present in the instruction. RS source register, we already talk about this. This is the source register, which is T2. RT is destination register, which is S3, this one, and immediate value 16 bit, which is 4 in that case, which is 100. The binary value of 4 is 100. So how we get OP? Here we use add immediate. This is the we use for here add. For add, here is the add. We use 8. The equivalent binary value of 8 is 1000. So this comes from here. We give the instruction using OP, and this is the two register and the numerical value is immediate here 4. So this is how it's work I format. You can see from here, this is our code and this is the process. This is the value, all the value 8 8 19 19 10 10 4 and the value of 4. This is how it's work. This is very easy and simple. So now let's jump about J format instruction, which is basically talk about the jump. So for J format, there is two instruction, which is 2 and 3. For jump we use 2, which is equivalent of 1 0 binary code, and address is this one. This is the address. This is the address, yes. For example, the address stored in J instruction is 26 bit of the address associated with the specified labels. The 26 bit are achieved by dropping the high order 4 bits of the address and low order 2 bits, which would always be 0 0 since address are always divisible by 4. Address equal to low order 26 bit of add format label table 4. So in the example above, if loop is at address 1028, then the value stored in the machine instruction would be 257, which is, we already know that we have to divide it by 4. Then after divided, we get the address which is 257 and the instruction is 10. Basically, it's a use in loop and any other jump in the program we if required. Now let's talk about R format, which is mostly used. Uh, have OP0, all of them 6 bit. In other format, I and J format, the instruction give in OP, but here OP is 0. Then RS, fast register operand, source register, which is source. This is the another source register, which is 5 bits. Always these are 5 bits. Then register destination, SSM SAMP, which is shift amount 0 when not applicable, which also 5 bits. Function, which code is 6 bit. Already I give you the idea of R format. Here is the details for add function. Here is the function 32. The binary of 32 is here. We use function for instruction. This is how it's work. This is the this is the S1. This is S1. This is S2 and this is S0. So this is basically the behind of the scene. Now let's learn about conditional operations. Branch to a labeled instruction if a condition is true, otherwise continue sequentially. We already know that the condition of, if we talk about C programming, if else, if A equal B, else if this not true, then let's come to else. So this is conditional, and for MIPS we use VEQ, branch if equal. This means branch if equal, and if we explore this, then if RS equal RT, then it's jump to L1. If branch equal means RS equal RT, then jump L1. If here is the things I already talked about here. If RS equal RT, branch to instruction labeled L1. Now let's another things, BNE, branch if not equal. This is the scene, then go to L1. So that's how it's work. And JL1, J format, we already know that unconditional jump to instruction label L1. If this is true, then directly it jump L1. If this is true, then it directly jump L1. If we discuss this code, this is the all thing we learn, and this is the implementation. Basically, this is the C program and this is the MIPS code. There is a two variable, so we set two variable by using add. We use zero register because the value of zero register is uh, always 0. Then 0 plus 5 is stored in S0, which is A equal S0 register, and this is S1, which is B, stored at 10. Then check if A equal B, then A equal 100. At the last, A equal A plus 5. So we check VNE, branch not equal. If branch A and B not equal, then jump to L1. Then add A, add immediate 5, A plus 5. Then J exit, jump to exit, then exit the program. So in MIPS code, always it's line by line execution. So we cannot write branch if equal. If we write branch equal, then it's go to this line, then this line, this line, this line. So the result not be equal. So if branch is not equal means A not equal B, then it's go to L1 and this line never be executed. If it's true, this one is true, and if this one is not true, then it's execute all the line. It's come here, then here, then here, then here, then here. So that's how it's work, line by line execution. We must follow this instruction and remember the things. If you practice more and more, then you can learn. And because this is a very complex programming, because we use backend compilation, so this is little bit of tricky. So I recommend you to practice more code so that you understand it properly. So that's all for today. Thank you everyone.